Hello everybody, my name is Satya. Welcome to this training where I will discuss about Python programming for interface parameter check. So when I say interface parameter check, we'll check the parameters that are constituted as part of a particular command. So as part of this training, I'll take an example of ipconfig, a Windows command. We'll run that ipconfig on the Windows command prompt and store that output in a particular variable, parse it, create a dictionary, and then use it to ping to those IP addresses that are assigned to the interface. So as you know, Python is a very powerful programming language with a lot of subroutines written to make the program run efficiently, right? So as part of this Python program, I have not used as part of my code any object-oriented concepts, but the modules that I use as part of the process, as part of the program, might contain object-oriented concepts because they are already compiled and integrated as part of the interpreter, right? So my program that I have written to parse the ipconfig command parameters, store it in dictionary, and execute a particular command on those, like a ping command to those interface parameters, is what I do as part of the program. And there I don't use any object-oriented concepts. So let's not dwell too much into the introduction. Let's go straight away and dwell into the code that I have prepared using Python, and I'm using editor as Notepad++. Okay, let me move the camera and show you the code. So as part of this, I'm storing the file as ipconfig.py, and this is the code. As you see, as part of the first few lines, I've imported few modules or subroutines that I'll use as part of this Python program. I use first one as import RE. RE module is a regular expression module which enables and gives power to the Python to parse a particular output and get what values we want from those particular output. So using regular expressions. Then I use import sys capability or the tool or a subroutine. This sys module is not used as part of this program as of now. The goal is to enhance this program and make it as a local network program where we execute different checks on the particular interfaces and check that they are working fine. So as part of this program till now, sys command or sys module is not used, but sys module is used to run system defined commands. Then the most important module that I use as part of this script is import subprocess. The subprocess module is used to execute CLI commands on Linux and Windows. I want to tell you here, for Windows it is ipconfig, for Linux it is ifconfig, some flavors of Linux as iplink, and some flavors as different command to check the IP configuration on a particular interface. Let's see what next. After declaring all the modules, I use result variable, and there I execute subprocess.run. See, clearly ipconfig is given and the output is stored in subprocess.PIPE. Then the result variable, I call stdout functionality module and store the output in result variable. Then I typecast result output to a string so that it is useful for me in parsing later in the code. Parsing means getting the output parsed and get the values that we want. Then I split the result variable with respect to new lines, right? This is also very important. Then I declare IPv4 address list, IPv6 address list, link local list. Okay, storing link local addresses. Then what I do is I need to iterate through result variable which is having the output of the ipconfig. For that I do for I in result variable, Then I use the most important and the intelligent and powerful commands here. If re.match, that means if a regular expression defined in the parenthesis matches any value in the stored in I variable, I will have one particular output of the result variable, or it may contain a complete output of the result variable. But we are only matching if we have occurrences of 0 to 9 plus dot 0 to 9 plus dot 0 to 9 plus dot 0 to 9 plus 4 bytes values are defined here. As we know, IPv4 is 34-bit length, that means 4 bytes. So we need to define 4-byte decimal digits here. So any decimal digit matching, either it can be one single digit or it can be multiple digits matching 4 bytes, that we need to capture and store it in IPv4 underscore address, right? So match does the match and goes into the loop, finds all the occurrences of this match and stores it in IPv4 underscore address variable. In the same way, we define it for IPv6 address. Here, instead of 0-9, additional A to F is used because IPv6 are hexadecimal values or digits. You know IPv6 as 1, 2, 3, 4, 5, 6, 6 into 6 tuples of hexadecimal digits are created, and that's why I use this IPv6 match here, where I declare one tuple as 0 to 9 AF plus, right, and separated by semicolon. And then again we check the output in I. If it matches, then we find all the occurrences of this match and store it in IPv6 underscore address. Then we check for linked local IPv6 address. First we match with the value starting with FE80. All the linked local addresses of IPv6 address space starts with FE80. So we say that anything which starts with FE80, there is a match, go inside and find all the occurrences of FE80 and store it in link underscore local variable. Then we define a dictionary, which is very important. Dictionary, as part of interface testing, whatever interface output you get, store those key value pairs in a dictionary, right? That is very, very useful further in the coding. Then you iterate through IPv4 underscore address list and find that if there is a match for IPv4 address format regular expression and does not match 255, which is the subnet mask address, and does not match colon, then store that address in the output or display that output as your IP address is the value IPv4 value. Then again you see here j is equal to I dot split dot. Now j is used, variable is used to split the IP address into 4 tuples, right? Because dot separates 4 tuples in IP address. Then check that the 4th byte is not equal to 1. Usually the gateway address will start with .1 as the 4th byte. So if it is not equal to 1, the 4th byte, then you display that address as IPv4 address. Your IP address is this, and in the dictionary put that value of IP address for IP address. Okay. Then default gateway, anything which matches or does not match above value, that is the 4th byte is not 1, and if it is 1, then default gateway is defined and stored, and the value is stored in IP underscore config dictionary. Then we check for re.match 255 in the variable I and see that if 255 matches any tuple with the IPv4 address, then that is your subnet mask. Then we check for IPv6 addresses with global scope, and then we have to iterate for IPv6 underscore address list, and then define, once that IPv6 address is shown, are found, then store that in the dictionary, that is ip_config. Then we go to link local, iterate through the link_local list and find the occurrences of link local and store it in ip_config dictionary. Then print the dictionary. Okay, so till here we are executing the code and storing it in the variables, but here we are printing it, right? So the next part of the code here, I show that below code goes to the dict created above and pings each value and determines if ping is successful for IPs defined on the interfaces. What I do here, for every key in the dictionary ip_config, I print saying pinging that particular value associated with that key, command equal to ping plus ipconfig, and the key is the iteration or index variable, right? Then I say subprocess result equal to subprocess.run command is nothing but ping command and store it in standard output. Okay, then result equal to store the result in result.stdout. Then typecast the result variable as string and split that string result variable with respect to new lines /r/n. Declare a variable count equal to 0 and then iterate through that result variable for I in result. If RE match reply, if there is a ping reply, if you find a keyword reply, increment the count and say that ping is successful. If the count variable still remains as 0, ping is not successful. So this is the code I have written, which I promise to improve in the next few classes by adding more functionality to it, right? So now let's discuss how the output of this program looks like. Let me just bring up the command prompt and show you what exactly I am referring to. Okay, give me a few seconds. Okay, now the command prompt is ready. This is the command prompt, right? Here I've already executed this and tested it, it's working fine. So now I just run python ipconfig.py. Once you run it, you see here it's getting executed, pinging the subnet mask, which will fail, ping not successful. Yes, default gateway ping will be successful. Yes, it is successful, but IPv6 address ping is not successful. I don't know for what reason, but link local address ping for both interface link local and the default gateway link local are successful. But I will go through the output again. Your IP address is 192.168.129.14. Your subnet mask is 255.255.254.0. Your default gateway is 192.168.128.1. IPv6 address on your interface for communication with global scope. These are the IPv6 address. IPv6 address on your interface for communication with link local scope. These are the two IPv6 addresses. One is your interface address, other is the default gateway link local address. Then the dictionary value, as I told you, we will be using this dictionary later on in further integrating further features into this program. Then this dictionary will play a very crucial role. So here you will see all the values with the keys are displayed. Then I ping each value associated with the key and see that for interface, of course, it should be successful. Subnet mask, no. Ping to subnet mask is not successful. Ping to default gateway is successful. Ping to global address, I don't understand why it is failing. I need to do some research. But anyway, for this program, you can already see that ping is happening to IPv6 global address, but it's not getting a reply. Then you ping to link local address, that is your interface link local address and your default gateway link local address, both are successful. So this is the output that will be as part of the execution for that Python program that I showed you people. So I'll put the complete code in the description. Please execute if you have time by storing it as a .py file. You can give any name you want and then run this code and see that if ipconfig values are being captured from your laptop also and whether it is displaying the values as it is shown here. Okay, thank you friends. We'll meet for the next video very soon. Thank you, bye.